Students, welcome back to the part 2 of lecture number 5. So, we started discussing about the probability and classification. First, let me go through the classification aspects, and then we will come back what is probability and how you can use probability and what is the Bayes theorem. That is the plan for next 25 minutes. Let me see how much I can cover. So, I told you that classification is a task of classifying things into different subcategories. Still, we might not be able to understand that this is what is the plant classification is, right. We know that plants can be classified in different ways. One way of classifying them is seed growing plants and non-seed growing plants, and then keep on developing other things, whether they are flower growing plants, non-flower growing plants, they have what kind of leaves they have. This is taken from the textbook of class 9 of CBSE, and therefore, this is what is classification is. Now, you understand, it is not a very big thing to be a difficult thing to understand. We classify the plants into different subcategories. So, now the question is, do you want to do it using a machine learning algorithm, right. So, what does it do? It predicts categorical class levels. It can be discrete or nominal. Discrete means, right, separates. Nominal can have different fractional values. Okay. It can classify the data based on the training set and the values in classifying attributes. Obviously, we always use certain set of attributes or features like dogs. They have a certain set of attributes, right, the color, texture, the way they look. Okay. Similarly, cats have different set of attributes. We have to use those attributes or features to classify them. You can also do a numeric prediction also, like models can provide continuous value functions, right. Why it is required? Many cases you have data, then you will have some missing values or unknown values, right. You can predict that using these numerical predictions. Typical applications are many. First is credit or loan approvals, medical diagnostics, so the tumor is cancerous or benign, fraud detections, if a transaction is fraud or non-fraud. Okay. You must be seeing different advertisement on your mobile phones that various companies can allow you to detect whether a website is fraud or not fraud. This is what they use. They use a classification algorithm to separate them. The moment you click it, if it is a fraud website, it will not open. If it is a non-fraud, then only it will open. So, that is a classification problem, typical. And so what is the difference between classification and regression? In regression, these algorithms are used to predict a continuous numerical output that you have seen, right. You are always predicting value of y when for certain new values of x, when you know the relationship between x and y. For example, regression algorithm can be used to predict the price of a house based on its size, locations and other features, which you think important, right. So, therefore, regression is basically providing you certain kind of a numerical values. A classification algorithm, they are used to predict a categorical output. Very rarely we predict a numerical output. We always predict a categorical output. Like, you can predict whether email is spam or email is not spam. There are many. Gmail has a spam folder, right? Google Mail. You know that they classify into spam mail and actually mail. Okay. You can have many such classifications in your Gmail. You can understand. Okay. You can see in your Gmail. You can understand that. So, well, there are basically two types of classifications in machine learning. One is called binary classifications, where you want to classify the input into two classes of categories. So, let us say for the basis of a health conditions of a person, we can always tell whether the person has disease or not. That is a binary classification. Whether I am healthy or not healthy, that can be decided whether I have any disease or not, right. So, that is basically a binary classification. So, that is widely used. Let us say you have a truck and you have a boat, right, and you want to classify. So, that is a binary classification. Obviously, the way trucks looks and the boat looks, they are drastically different. So, it is easy to classify them. So, you can also have more objects, like you have truck, you have a plane and you have a boat, right. You can also classify that plane is an object which flies in the sky, whether on the other hand your bus is a truck and boat does not fly. That is one of the classification aspects you can use, right. So, between boat and truck, the major classification is used, you can shape the way it looks like, right, very simple. But plane from the front sometime may look like a vehicle or basically truck, not truck, but vehicle, right. So, therefore, it is better to use whether it can fly or not as a prime feature to detect whether it is a plane or classify as a plane, right. So, you understand, right. You can also have multi-level classification problem, that is called binary. In multi-level classification task, we try to predict 0 or more classes for each input. For example, okay, it is used in various domains like auto tagging in natural language processing, given a text whether it contains multiple topics or not, right. Yeah, you have a text, you can always find out whether it contains multiple topics or not, or it contains say one topic or two topics. The book you find out, you can have either single topic or two topic, or it can have multiple topics. Similarly, in computer vision, you can always have multiple objects like here truck, boat, plane and a dog, right. You can see that. So, here you have to develop a machine learning algorithm which can use multi-level classification problem. Each of these has different features. Remember, first three is basically a vehicle and dog is an animal. So, hence there are messages all kinds of algorithm we use. You can use region trees to do that, you can use random forest to do that, you can use gradient boosting or GB to do that. We are all going to discuss each of these things in this course. So, therefore, you do not need to run away, you will understand these techniques, how these work, what are the important features of these techniques very nicely. Well, in order to provide you more details about the multi-class classification, training data of this input associated to the class level, you can have a number 1 to k, and then you can predict given input whether you can predict class level. Well, that is how it is done. This is basically called K classes problem, K class problem. Now, I also like to tell you one more important aspect, that you can have different kinds of learners. See, you are going to use the data to make the machine learn, right, first. That is what is the job of machine learning. You have data which is basically we consider as experience, and that data is used to make the machine learn. So, there are two types of learner possible. One is called lazy learners, other one is called eager learners. Very, very nice sentences, right. There is always some students in the class who are very lazy in learning, and there is always some students in the class who are very, very eager to learn. Similarly, you can also have algorithms which is either part of lazy learners or part of eager learners. What are lazy learners? Simply stores the training data and wait until the testing data appear. Do you understand that? Well, let me explain. So, all the models basically learn from training, and then they after learning they are tested. So, what do you do? If I have a large amount of data, I divide the data into 16 to 40 ratio between training and testing, or 18 to 20 ratio between training and testing. So, in the first case I use 60% data to train the machine, to train the model, right. So, what they do, it stores this training data and wait for this testing data to appear. This is lazy, it does not make any effort to get tested, okay. It is using only testing data to learn, and I wait to take the exam, okay. I do not do, I am very much inclined to go to the classroom and take the exam. I learn, but I wait. So, that is what the lazy learners do. So, now what are the eager learners do? Eager learners, they construct a classification algorithm based on the training data before getting the data for predictions. Remember that. That means before testing, it will construct a algorithm. They are very, very quick, right, very, very quick to learn. So, before even getting tested, they can actually construct a model and keep the model ready. So, immediately whenever the testing data appears, they test the model. That is the difference between lazy and the eager learners. To give you more, lazy learners are also called instant based learners, do not create any model immediately after learning, immediately from the training data. This is where the lazy aspect comes into picture, they wait, right. So, they have just memorized the training data, remember these sentences, they memorize the training data and each time there is a need to make a prediction, they search for the nearest neighbor from the whole training data, and that makes their prediction very slow. Okay. Basically, they do not create any model at the beginning from the training data. Whenever the instance arrive is for testing, they basically select algorithm and run it. That is what they do. There are couple of examples. One is called K nearest neighbors, other is called K space reasoning. These are the lazy learners we know. The eager learners, they actually first built a model. Regression is a model, by the way. You may be thinking, what is a model? Sir is talking about it. Regression is a model, like, by the way. Okay. So, they just built a model from the training data itself before even making any predictions. They keep the model ready and they wait when they are asked for predicting, they can predict. So, they spend more time during the learning stage, during the training process, because of their eagerness to have a better generalization during training. They are very eager to learn or generalize the data to find a correlation or functional relationship with the data, input and output variables during the training itself. Okay, that is why they can predict quickly. Compared to lazy learners, they can predict quickly. And each learners develop a classification model based on a training data set before even receiving a test data sets. That is what is the difference between lazy and eager learners. Please remember this. There are many eager learners. Logistic regression I already talked about in the last part of the lecture is a part of a eager learner. Similarly, support vector machine, which we will discuss, decision trees and artificial neural network, they are all part of eager learners. So, K nearest neighbor is a part of lazy learners, right, and these are the part of eager learners. That is what I wrote, one is known by its action, but if you go back here, one is known by the company it keeps. That is what a lazy learners does. So, classification is basically two steps process, you have to understand. So, you understood classification is, you understood what kind of models are there. These are the different models used for classification. Remember, I have not put naive Bayes. Naive Bayes will also come under eager learner. Okay. So, classification basically is two-step process. What is that? First, you have to describe a model or construct a model. So, model actually describe a set of predetermined classes, and what does it? Sample is assumed to belong to a certain class. Very simple. You have, suppose, let us say you have many categories of dogs and cats. There are many types of dogs, right? Labrador dogs, your Himalayan husky dogs, Siberian husky. So, you can actually divide them, by using set of predetermined class. And remember, model is represented as a class if certain rules or decisions exist. Okay, you can use formula also. And there are few things which determines whether the model is doing well or not. One is accuracy, other one is the test set. That we will talk a little later. So, what is the first step in the process? First is the model construction. To give an example, let us say I have this data. I have a name of the faculties, their ranks, and how many years they spent, and whether they got permanent job or not, tenure, right. So, if Mike has spent only 3 years, so he has not got permanent job or tenure. Whether Bill has spent 2 years, but he got tenure, very interesting. And similarly, Jim, which is associate professor, he has got spent 7 years, he got tenure, right. So, as you understand, associate professors can get tenure based on how much time they spend and what is their rank, right. So, assistant professors are not. So, that is the classification process, right. So, classification algorithm is basically going to classify this. If the rank is professor or experience is more than 6 years, then you make them permanent. That is what is the algorithm, that is the model, remember that, that is what the model is, right. If the rank is professor, full professor, or X number of years spent is basically more than 6, then the person is considered as a tenure or permanent faculty. If this condition is violated, if the person is not a professor or a person has not spent more than 6 years, then person is not tenure or permanent. So, this is what is the model construction, this is the process number 1. Now, once you have developed this model, second thing is using this model for prediction, correct. Now, you have data, Tom, assistant professor spent 2 years, obviously he is not tenured. But if you look at George, he is a professor and he has spent 5 years, so obviously he is a tenured faculty. Like let us talk similarly, unknown data is Jep, who is a professor and spent 4 years. Is this tenured? Answer is yes. Am I clear? So you understand this is how actually it can classify the whole thing. So there are 2 steps. First we develop the model, second step is using the model for prediction. Okay. So now I have talked about it, about a little bit of classification. Next 10 minutes or so, let us talk about the name base. Name based classifiers basically are supervised machine learning models that uses Bayes theorem of probability. And so here we are going to provide you an overview of that and how implementation is done. Basically it talks about Bayes theorem. So you must know what is Bayes theorem, then only you can do that, right. So let us talk about it a little bit on that. What is Bayes theorem, what all things we can do. But before that, let me tell you some concept of probability. You know what is probability, right? All of you know. Okay, if you don't know, very simple. You take a coin and just toss it. Either you will get head and tail. Now if I say if I do 10 times this experiment, how many times I should get tail or how many times I should get head? Can you calculate that? So therefore, that is why the probability come into picture. Probability is how likely an event can occur, right. Probability is what? How likely an event can occur. Very simple. If I have one coin and toss it, probability of getting head is half, probability of getting tail is also half. Because if I throw this coin, I can either get head or I can get tail. So there are 2 possibilities, head and tail. There are 2 possibilities, head and tail. Okay. So that is why each can happen. That is why it is 1 by 2. Remember that. That is what is the probability is. You can many of you play, dice, right? Ludo or something, and then you throw a die. Die has 6 faces, 1 to 6, 1 dot, 2 dots, 3 dots, 4 dots, 5 dots and 6 dots. Now if I ask you what is the probability if I throw a die of getting 6? How can you calculate that? So think about it. Okay, that is what it is. So probability is related to how likely an event can occur in a particular situation. Okay, you can play cards. There are 52 cards in a playing card situation. And if I ask you what is the probability of getting the jack of a spread for 52 cards, what will it will be? You have a random number of distribution of the cards and you are asked to remove one card. What is the probability that you will get that card as a jack of spread? Can you calculate that? Think about all the aspects. This is what is called the concept of probability. Okay. So now we always define a probability as simply what? Probability is defined as a favorable outcome divided by total number of outcome. Remember this. This is what is used for definition of calculation of probability. Favorable outcome divided by total number of outcomes. And we can always write P probability of any event experiment E, that is equal to N E divided by NS. So here NS is the total number of outcomes and probability of E is favorable number of events for E. Okay? That is what is when you toss a coin, probability of getting head is only half chance, because there are 2 sides of the coin, right? That is why. So this become 1, this become 2, obviously, correct? That is what it is. But remember, this doesn't, this probability is after a lot of many experiments. It is not like 1 or 2 experiments you do many experiments, then you calculate, then you will get this probability. Okay. So, as you understand that you can play, you can always have, that if I toss a coin, you can have a probability of head or tail, right. So, you can always tell the probability of head is PA and probability of getting tail is PA prime. So, PA is an event and A prime is an event which is opposite to that. Okay. So, therefore, total probability of PA plus PA prime is 1, right, has to be 1. If I do a random experiments of a coin and calculate probability of getting head and probability of getting tail, add them, it will become 1, because probability this P basically is always varies between 0 and 1. It cannot be more than 1 and it cannot be less than 1, 0. So, probability is basically a fraction always, remember this. So, this event P A prime is basically called complementary probability. Am I clear? This is called a complementary probability. This is the probability of A, P A prime is a complementary probability, opposite, okay, like complementary angles, you know that, right, same thing. You can also have other aspects, other kinds of probabilities, okay, you know that, right. So, therefore, if I write down this, so you can also have a situation what is called joint probability. Do you know that? In case if you know, that is good. Joint probability. What is joint probability? Joint probability is probability of A cross B, that is nothing but PA dot this is what is called conditional probability. Okay. So, you have to describe all these aspects in a detailed manner, what is joint probability, what is conditional probability, what is that, right. These are all you should know very well nicely, then only you can explain this. Okay. So, joint probability is what, let us explain that, because this is where the Bayesian theories comes into picture. Probability that both an event can occur is called a joint probability. I have tossed a coin, right, and you have tossed a coin, okay. What is the chance that both of us get head? That is a joint probability, right. So, this is the probability that both the events occur that is what is called joint probabilities, and this is always written as a like this P probability A cross P, A intersect P, right. Do you understand that? What is A intersect B? Let us say this is what is set of A and this is what is set of B. Now, this region which is for both, this is what is called intersection region between A and B sets, that is what is P intersection B. Okay. Am I clear? So, now this denotes that events, both the events A and B are occurring simultaneously. At the same time, you are throwing the coin, I am also throwing the coin. That is what it talks about it. So, this basically can be written as a like this. written. Okay, that's what it is. PA times PB by A, and we will then talk about what is B by A now. Am I clear? Let us talk about what is B by A then and what is the conditional probability. Okay. So, I hope you understand that what is the joint probability. Now, probability for each event A to occur under the condition that event B has already occurred is called conditional probability. Okay, that is what it is. So, let me write it down here on the left side. I have discussed what is joint probability. Remember, these all will be required for Bayes theorem. That is why. So, point number E is what is we are talking about, conditional probability. Sorry, E. So, remember joint probability when both the events are occurring simultaneously. So, conditional probability, very important concept. What is that? Probability, the probability for any event A to occur under the condition that event B he has already occurred. That is what is called definition of conditional probability. The probability of for any event A to occur, we are calculating probability of any event A to occur, but under what condition? Under the condition that B has already occurred. You have already gone to Mussoorie, what is the probability that I will also go? That is what is the conditional probability. Shall I follow you and go, or shall I not follow you and go? Okay. I go, I may not go to Mussoorie, I will go to something else, right. So, that is what is the conditional probability, right. There are many aspects possible, but we calculate the probability of any event A to occur when under the condition that B has already occurred. Am I clear? So, now this is determined, this is written as a P A by B, probability of A when B has already occurred. Remember this, probability of A, this is not written like this, there is a way to write probability of A slash B when probability of A when B has already occurred. Now, this is given, I am not going into details of probability because this will may take a lot of time. This is obviously given as a P A union A cross B intersection B divided by P B. That is what it is. This guy is what? This guy, you can clearly see P probability of B by A, this is probability of B of probability of occurrence B when A has already occurred is nothing but probability of A intersection B divided by probability of A. That is what exactly we did. This is your conditional probability. So, joint probability depends on conditional probability. Am I clear? So, now if these two events are mutually exclusive, they do not depend on each other, then what do you do? We can say this is 0. My going to, you are going to Mussoorie and my going to Mussoorie does not depend on each other, there is no connection, then the conditional probability becomes 0. So, let us stop here. These are the very difficult concepts in which you should read little bit textbooks and understand that condition probability and joint probability, because the whole algorithm, classification algorithm will depends upon Bayes theorem, and Bayes theorem depends on these concepts. So, these concepts you should know very well. I am only giving you tips of the iceberg, let me tell you, because there are so many things to be learned. I assume that in your college or in your university you have already understood, already learned what is probability. Probability depends on what factors, you already understood that, right. That is what my assumption, because if I keep on talking on these aspects, this may take a long time. So, hence I request you to study from textbooks about the probability aspects and come back. So, when I talk in the next lecture, that is lecture number 6 about the Bayes theorem and how the algorithms looks like. Let me stop here. Thank you.